As you know, the winds in the upper atmosphere create and drive all the weather, even the weather down below. So it's important to you, as an instrument pilot, to know how to read and interpret the upper air weather charts. Besides that, when you become a citation pilot, you'll need to know this stuff anyway. One of the charts which can help you make good weather decisions is a constant pressure chart, and it's very similar to the surface analysis chart. There are 6 different constant pressure charts produced by the National Weather Service, ranging from 850 millibars or 5,000 feet all the way up to 200 millibars or 39,000 feet. What you get from these constant pressure charts are observed winds and temperatures, as well as the temperature dew point spread, and all for the altitude of your choice. The way they observe this stuff is with weather balloons. The weather balloons are released twice a day, and the times on the charts correspond with the balloon release times. Another way to determine observed winds and temperatures aloft is this chart, the Winds and Temperatures Aloft chart. But don't confuse this chart with the Winds and Temperatures Aloft forecast, which covers forecast winds and temperatures. This Winds and Temperatures Aloft chart covers observed winds and temperatures. Now, this particular one is for an altitude of 34,000 feet. You'll notice that these charts use the same station symbols as many of the weather charts we've covered so far. There are, however, some subtle differences, which we'll examine in just a bit. But first, move up to the Boise, Idaho area, and you'll find it at letter B. This number right here, the minus 49, tells you that the temperature there is minus 49 degrees C. Nothing new there. And you remember from the charts that you've already seen that the arrows tell you the direction the wind is from, and the pennants and barbs tell you the wind speed. As you recall, each pennant represents 50 knots of wind, the barbs represent 10 knots, and the half barbs are 5 knots. So in this case, the wind speed here is 95 knots. But here's one of those subtle differences that we just mentioned. If you look just below the arrow, you see the number 5. Now, you can tell by the arrow that the wind is coming generally from the west. And as you know, westerly directions are 250 degrees, 260, 270, 280, and so on. The number 5 indicates the middle digit of the specific wind direction. So in this case, the wind is from 250 degrees, and that's relative to true north, because our winds for weather purposes are relative to true north. Now, another difference on this chart is the station circle right here. When it's shaded in, as you see, it indicates that the temperature and the dew point are within 5 degrees C. It does not indicate overcast skies as it does on other weather charts. Now, this chart is called the Tropopause Height and Vertical Wind Shear Prognostic Chart. What a mouthful! But just as its name implies, it tells you the forecast height of the tropopause and also the amount of vertical wind shear that is forecast in different areas. You can use this chart when you've upgraded to your citation jet and you're searching for jet stream type tailwinds or trying to avoid wind shear turbulence. So move up to Montana and take a look at arrow A. You can see the black rectangle symbol with the F300 printed in it. This symbol depicts the height or the flight level of the tropopause in that area. Now, as you've done with most of the weather charts, you add 2 zeros to the number shown to come up with the height. So in this area, the height of the tropopause is 30,000 feet or flight level 300. Now move down to arrow B and notice the 6K symbol in this dashed line. It tells you that in that area, for each 1,000 feet of altitude you go up, the wind changes or shears by 6 knots. You should expect turbulence due to vertical wind shear whenever the wind changes 6 knots or more every 1,000 feet, as it does here. So, With a visit to your local flight service station, you can access all of these weather charts to help you make better high-altitude weather decisions. And like we mentioned way back at the start of this lesson, we all talk about the weather, but it took the government to do something about it. This is one of those rare cases of your tax dollars doing actual work. Kind of makes you all warm and gooey, doesn't it? That the government cares so much about you as a pilot that they make all this information available to you. But seriously, you get it all for the price of your fuel tax.